let's look at esters. Esters have a C double bond O, an oxygen, and then a carbon on the other side. This has the general formula RCOOR, and it can be written as RCO2R. Notice that we do have an R prime. We call that R prime. Just means that the R groups can be the same or possibly different. Very likely to be different in this case. There is no name for the functional group ester. I do want to remind you that I like to remember that esters are esters because they have two ester eggs. I know it's not the right way to say it, but if you think about it, it looks kind of like Easter and it looks like Easter eggs. It'll help you to remember the difference between ester and ether, which are very similar in name. We'll come back to the physical properties of esters later. For naming esters, it is basically like naming a carboxylic acid. We end the name with O8 instead of oic acid. It is all one word now. We put AN in front of it to tell us that it's all single bonded. We put how many carbons are in the main chain that must include the carboxyl type group, the C double bond O, as part of the main chain. Then we add on substituents, giving them numbers as needed. In front of that, we're going to put a first name, and that first name is the attached group that's attached to the oxygen. We're not going to tell you that it's attached to an oxygen except by telling you that the ending is O8, which means that there's an oxygen with another carbon group on it, and so we will see it as a separate group. And then we're just going to give you the name of that group, whatever its normal name would be. If it's 2 carbons, it'll be ethyl. If it's 3 carbons, it would be propyl. So we attach that onto the front of the name. That is a separate word from the rest of the compound name. And that's the basics. Let's try some. We'll start with letter A. We're going to look at it, find our functional group. Notice that we have a C double bond O and another oxygen, and that there is an R group on that oxygen. That makes this an ester. That tells us that the ending will be O8. In front of that, we're going to put AN because everything else is single bonded. And then in front of that, we're going to put in the main chain. Now, how many carbons are in the main chain? Well, we have 2 carbons or 1 carbon. And we're not going to choose the longest one now, but remember, it's the longest one that includes that carboxyl-like group, so with the C double bond O carbon on it. So it must be included as part of it. In this case, it is going to be the 2-carbon chain, which happens to be longer, so that is going to be ethanoate. And then we just talk about the attached group, in this case 1 carbon, which would be methyl. And we will have methyl ethanoate. Notice that I did not put a number in on the main chain, and that's because the ester is on the end, and it will always be number 1. Let's look at compound B. In compound B, we see that it's an ester. I'm going to point at the side that should be the main chain. And now we're going to look at the naming. So it's an ester, so we end with O8. In front of that, we put AN to indicate all the single bonds. And in front of that, we put in our main chain. The main chain must include that ester group, the carbon that has the C double bond O and the oxygen on it. And so in this case, that will be the one with 3 carbons, and that will be a propanoate. The attached group has 2 carbons. This is ethyl propanoate. That is the whole name. Let's look at compound C. We're going to see that we have an ester, so the ending is O8. Everything else is single bonded, so it's anoate. If we pointed at the chain that is the main chain, it will come from those 2 oxygens. We point at that carbon, and we see that it is only 2 carbons long. That means this is an ethanoate. And then we're going to put the branch on the other end of it, and that is propyl. Notice that the longer chain is not the main chain. It is the one that includes the C double bond O. So our answer is propyl ethanoate. Let's look at compound D. We see that it's an ester. Let's go ahead and point at the main chain. Then we're going to have this as an O8 with AN in front of it, anoate. We put in how many carbons for the main chain. In this case, it's only 1 carbon, much shorter than the attachment, but that is still our main chain because it holds on to both parts of the functional group. So that is now going to be a methanoate. And then we're going to add on our attachment, which is 4 carbons long, so it's a butyl methanoate. We look at compound E. We see that we have an ester, so it's O8. We write AN in front of that to indicate that everything else is single bonded. Now we need to look for the longest carbon chain that includes the carbon with the C double bond O, our carboxyl type group. And we see that that is 2 carbons long, so it's an ethyl group. So we have an ethanoate. We also have a branch that is 2 carbons, so this is going to be called ethyl ethanoate. And that is the naming of esters. Interestingly, esters are known for their smells. Sometimes they smell sort of like glue, nail polish remover, and then sometimes they smell fruity. As you go down this list, you'll see that they become more and more fruity. The smaller ones tend to smell more like glues and more chemical smelling. These are often used in foods to make them taste like they smell. So we'll see strawberry scented, pear scented, apple scented. All of these are used for those types of flavorants. And finally, let's draw some esters from their given names. So let's start with A, heptyl 2-chloropropanoate. As usual, we're going to start at the end. We're going to see the O8, which tells us that this is an ester and that we will need a C double bond O and another O somewhere on this structure. Then we see it's a propanoate. We see it's all single bonded with 3 carbons in the main chain. Let's go ahead and draw those in. Now that we put in our C double bond O, we're going to add on to the oxygen. We're going to add 7 carbons as we see that it says heptyl. So it's 7 carbons on that oxygen and then 3 carbons in our main chain. We'll go to carbon 2 on the main chain and we'll put our chloro on there. And that is our carbon skeleton. Now we just need to add in all of our hydrogens, making sure that every carbon has 4 bonds, every oxygen has 2. Beware of where that C double bond O is. We don't want to add an extra hydrogen. And that is our heptyl 2-chloropropanoate. Let's look at compound B, isopropyl 3-propyl nonanoate. Kind of sounds a little funny, but it's not too difficult. We look at the end first. We see that there's an ester because it ends with O8. In front of that, we're going to have AN. The AN indicates that everything else is single bonded carbons. And then we see nona. Nona means 9. So we're going to have 9 carbons in our main chain. We draw those out, and now we're going to put on our C double bond O for their ester group. We can start on either end, but whichever one we choose, that will be the new number 1 carbon. So let's put it on the far side here, and we're going to make that our O8. Now let's go ahead and add other things on. We see isopropyl. That is a 3 carbon chain joined in the middle of the 3 carbons, and that one is attached to the oxygen of the ester. So we'll go ahead and put that one on. And then on carbon number 3, we're going to put a 3 carbon chain, but this one is going to start at the beginning of the 3 carbons. And there we have it. We now have our carbon skeleton, and the last part is to add the rest of the hydrogens in, and we will see that we have our product. This is isopropyl 3-propyl nonanoate.